Hello friends, welcome back to Shibi's chemistry classes. Today we are going to start the new chapter, that is analytical chemistry. This chapter is somewhat related with the previous one, acid, bases and salt. But here we are going to study about color of certain salts and its solutions. So in acid, bases and salts chapter, we have studied about salts, how they are formed, what is their preparation method, what are their properties. But here we are going to see the color of the salt and its solution, and we are going to detect the presence of certain salts in the given sample. Action of sodium hydroxide and ammonium hydroxide to salt solution. First we'll add these reagents drop by drop and in excess. See, mainly we have to deal with these points, means we'll be given a certain sample and we have to detect the presence of certain salt in the given sample, and by on the basis of its color or by using these two reagent. What reagent? Sodium hydroxide and ammonium hydroxide. So let's come to the main chapter. See, when we are saying that detection of salt in the given sample, so that detection that we are going to do is called analysis. So in chemistry, analysis, when we are talking about analysis, it could be done in two ways. One is qualitative analysis, and quantitative. So here in this chapter we are going to do qualitative analysis, means only detection. Composition if we have to determine the composition of the given substance, then it could be done by quantitative analysis, whereas if only we want to detect the presence of certain salt, that could be done in qualitative analysis. So this qualitative analysis now we are going to discuss in detail, but for that we should know the color of certain metal cations. So as we have completed acid, base and salts chapter, so by now you all are familiar with salts. And when I am talking about salts, that means they are compounds that are formed by the partial or complete replacement of hydrogen from its acidic solution by a metallic cation. So when I am saying salt, so we know that salts are formed by the partial or complete replacement of hydrogen from its solution. So how? Like here it is sulfate. We have to replace this hydrogen by a metal cation. Its valence is 2. Similarly, K2SO4. This is also metal cation. Calcium sulfate, magnesium sulfate, ferric sulfate. So these are some of the salt that are produced by replacing both the hydrogen from this sulfuric acid. Similarly, this is hydrochloric acid and we want to replace this hydrogen by these metal ions. Ferric chloride, magnesium chloride, calcium chloride. Many examples are there. And this is nitric acid. We'll replace this hydrogen and form a salt like NaNO3, lead nitrate, calcium nitrate, KNO3. So these are the salt, and we want to detect the presence of these salt in the given sample. See, when you go to lab, you will get this experiment to perform. You will be given a sample, an unknown sample. You are not knowing what salt is present in that sample. So you have to detect the presence of certain salt. Means it could be this salt, or any of the salt. You have to detect it. So how that detection could be done, that we are going to study now. See, elements of group 1, 2 and from 13 to 17. These are called representative elements or main group element. Group 1, 2 and from 13 to 17. We know that group 1, 2 elements are all metal, and from 13 to 17 they are mostly non-metals. So 1, 2 and 13 to 17, these are called representative element or main group element, and these elements are generally colorless. Only few ions are colored, so that we'll discuss separately. Here, just keep this in mind that whatever element is present in group 1, 2 and from 13 to 17, they are mostly colorless. And from group 3 to group 12, 3 to 12, they are called transition element. We have studied periodic table, and in that table we have seen that elements that are present in between these two, 1, 2, and here we are having this 13 to 17, and this is 1 to 2, and from here 3 to 12. So these are transition element. The elements that are present in between these two groups, they are called transition elements, and they are mostly colored ions, like iron, copper, and they generally are colored. Nickel, chromium, manganese, these are all transition elements. Now we'll see which element are colorless and which are colored. We'll make a table. First we'll see metal cations. Cations means positively charged species, like ammonium ion, sodium, potassium, calcium, magnesium, aluminium, lead, zinc. These are all positive species, and that is why they are called cations. So valency +1, +1, +1. Here it is +2, +2, +3. Lead is +2 and zinc is +2. So they are all colorless. What type of ions are they? They are all colorless. Similarly, anions, we write anion here. So these two, cation and anion, both are colorless. What are the colorless anion? Chloride ion, sulfate, carbonate, nitrate, bicarbonate, sulfide, bromide, acetate. So these are colorless anion and these are colorless cation. Now we have to see colored cation and anion. cation, anion. So colored में the first is Cu. This is cupric ion. Cu2 plus. Cupric ion, ferrous ion 2 plus. Ferric ion Fe3 plus. Nickel, chromium, manganese. Nickel Ni2 plus, chromium 2 plus, and manganese also 2 plus. Now what are the color? This is blue in color. This is green. This is yellowish brown. Nickel and chromium both are green in color. This is light green. Ferrous iron is light green in color. Nickel green, chromium also green, and manganese pink. So only few ions are colored, so you could easily learn it. So whenever these ions combine with a negative anion, it gives the color of this particular ion. Suppose if you combine this copper with, say, nitrate. So we have a salt, copper nitrate, and we know that copper here is in +2 valence state. So this copper has blue color, so the resulting solution will be blue in color. Similarly, if you combine this ferrous, in ferrous iron is in +2 state. So ferrous sulfate, and from this table we know that sulfate ion is colorless and this ferrous is light green in color. So the resulting solution could be light green in color. Similarly, any like ammonium chloride, if you combine this ammonia and chloride ion, you will get ammonium chloride and it will be colorless. Sodium sulfate, colorless. And what else? You take any colored ion from here. Ferric chloride. What is the formula of ferric chloride? FeCl3. Color of ferric iron is in +3 state. Its color is yellowish brown. So the resulting solution will be yellowish brown. Because this chloride ion is colorless. Now we'll take some colored anion. Permanganate, dichromate and chromate. Permanganate pink or purple. This is dichromate and this is orange in color, and chromate ion is yellow in color. So these are some of the cations and anions that are colored and colorless. So we are going to study salt of these ions. So some salts could be easily recognized by only preliminary examining it by its color, because only few are having color, so we could easily identify the salt by its color. Suppose you are having a blue colored salt, that means immediately you could guess that it is of copper salt. And if you get yellowish brown color, then it is of ferric salt. So on the basis of color, you could easily identify the given salt. But what if the sample is colorless? Because most of the ions, they are colorless. So for that we use reagents. So these reagents are NaOH and NH4OH. So they are the best lab reagents, and we add these reagents to the salt solution and we'll get a precipitate. Whenever these reagents are added to the salt solution, it easily precipitate out the insoluble substance from the solution. Precipitate means whatever is insoluble that gets separated from the solution and get deposited at the bottom of the test tube. So, and by seeing or then by noticing the color of the precipitate, you could easily identify the presence of certain salt. So now we'll see the effect of these reagent on certain salt solution. First we'll see the effect of NaOH and then NH4OH. Salt solution plus alkali. You know NaOH and NH4OH, they are called alkali, water soluble bases. So you will get a precipitate. What precipitate? Precipitate of metal hydroxide and a soluble salt. Then we will notice the color of the precipitate. First, salt will take of calcium. We know that its valency is 2. And what calcium salt we will take? We will take calcium nitrate. Calcium nitrate, valency of calcium is 2, valency of nitrate is 1. Then we will add NaOH. You will get a precipitate of metal hydroxide. So this is metal and this is hydroxide. So combine it, CaOH twice because valency of calcium is 2 and 1 salt, NaNO3. So we have to observe the color of this precipitate, calcium hydroxide. So we know that calcium is colorless, so calcium nitrate will be colorless. Caustic soda is colorless, but the precipitate that we are going to get, it is white. So white precipitate. And if excess of NaOH is added to this white precipitate. See, here in this reaction, while we are performing the reaction, we could add only a very little amount of reagent. Firstly, we add little amount of reagent drop by drop from the side of the test tube, from the test tube wall. Then immediately you will get this precipitate and you observe the color of the precipitate, and then you have to add the reagent in excess. Reagent will add the reagent in excess, and then you have to notice whether the precipitate is soluble or it will remain insoluble. So what happened when you add a reagent in excess? This precipitate will become sparingly soluble. So if you get a white precipitate by the addition of sodium hydroxide reagent, then you could presume that the given salt could be a calcium salt. Second, we'll take iron. And we know that iron forms salt in two states, 2 plus and Fe3 plus, ferrous and ferric. So first we'll take ferrous sulfate, and ferrous sulfate is light green in color. We know that ferrous iron, it is light green in color, and sulfate is colorless, so the resulting solution could be light green, and we have to add NaOH to it. See, in this chapter you will get questions related to these equations, so you have to learn it. There is no other choice. You have to learn all the reactions very nicely. Then what could be the possible product? Metal hydroxide. Metal is iron, hydroxide is this. Combine it, and we know that iron is in +2 state, so it will be this, and this a precipitate, and the precipitate would be dirty green. And one salt, what salt you are going to get? Na2SO4. Na2SO4, sodium sulfate, could be colorless. And if you add excess of reagent, it would remain insoluble. See, these are the observations. While performing the test, you have to note down all the observation. Here what happened? You got white precipitate, and white precipitate you could possibly assume that it could be a calcium salt. And on addition of excess of NaOH, it is sparingly soluble. And it is not totally insoluble, but yes, it dissolved a little bit. But here, what happened here in this case of ferrous sulfate? When you add NaOH, you got dirty green gelatinous precipitate of ferrous hydroxide, and on addition of excess of NaOH, the precipitate remained insoluble. So this is a specific color of ferrous salt, dirty green. So when you get a dirty green precipitate, you could immediately give the inference that the given salt is ferrous salt. Next is ferric salt. Ferric, we will take ferric chloride. Best salt is ferric chloride, and it is yellow in color. Caustic soda, colorless. What you are going to get again? This time ferric hydroxide as a precipitate and reddish brown. Plus salt NaCl, and this is also insoluble in excess of sodium hydroxide. So we have seen calcium salt, iron salt, iron in +2 state and iron in +3 state. First we took ferrous sulfate and then ferric chloride. Now next example is copper salt. And we know that the color of copper, cupric iron, is blue. Copper salt, formula, symbol is Cu, valency is 2+. This is cupric iron. We'll take copper sulfate. The reagent is sodium hydroxide. You will get metal hydroxide, precipitate, which will be of blue color, and then Na2SO4. This is colorless in solution. And what would happen if you add excess of NaOH? The precipitate will remain insoluble. So in calcium salt, we got white color precipitate. With iron, we got green and reddish brown color, and with copper, we got blue colored precipitate. Next is zinc. Symbol is Zn in +2 valency. We'll take ZnSO4 and we'll add NaOH to it. So form the metal hydroxide, ZnOH twice and Na2SO4. So this is a special case because its hydroxide will get dissolved in excess of NaOH. And the color is white, gelatinous. Gelatinous means with glaze. The precipitate that you could get will appear shiny. So white gelatinous precipitate. This is colorless. And what will happen? Precipitate becomes soluble. with excess of NaOH. Now we have to see that reaction also when you added excess of NaOH where to ZnOH. NaOH in excess. So the precipitate get dissolved and form sodium zincate. And it could be colorless. So this is important reaction. You could get this type of questions like what would happen if you add excess of NaOH to zinc salt. So you have to show this reaction first. You have to make reaction with NaOH and then form white color gelatinous precipitate zinc hydroxide is formed. And when you add excess of NaOH to the solution containing this precipitate, you will get this precipitate will get dissolved and sodium zincate is formed, that is colorless. So this is important reaction. Next is lead salt. So lead will also get dissolved with excess of NaOH. Lead symbol is Pb, valence is +2, we'll take lead nitrate. Please balance all the reactions because I have not done it, but you have to do it for your practice. Lead hydroxide, white precipitate plus NaNO3, sodium nitrate colorless. Because both sodium and nitrate both are colorless, so the resulting solution will be colorless. And this precipitate will also get dissolved. So in the first example, we have seen calcium salt. Calcium salt also produce white precipitate. So how could you distinguish between both the salt? So in both the cases, you are getting white precipitate. So how could you assume that the given salt is a calcium salt or lead salt? Just try to recall. In case of calcium salt, the metal hydroxide precipitate that we have got over here remained insoluble in excess of sodium hydroxide. Why we are doing this test? Because somewhere you are getting the same color precipitate. So just to confirm, it is a further confirmatory test. So for the confirmatory test, what you have to do, if you are getting white color precipitate, you have to put excess of NaOH. So in case of calcium salt, when you added excess of NaOH, the precipitate remained insoluble. Whereas in case of lead nitrate or lead salt, you got white colored precipitate of lead hydroxide, and when you added excess of NaOH to it, it get dissolved. So this will give the confirmatory test for the presence of lead salt or calcium salt. NaOH in excess, you will get sodium plumbate. Sodium plumbate, and that is also colorless. And the last one that you have to study is of ammonium salt. Ammonium salt, NH4 plus. We take ammonium salt. So when sodium hydroxide or any other water soluble base is heated with ammonium salt, ammonium gas is evolved. So we took ammonium chloride, then added sodium hydroxide, heat it, you will get salt, water and ammonia gas. Take another ammonium salt. So in these reactions, we have seen the effect of reagent sodium hydroxide on certain salt solution. So what we did, we took the salt solution, we took the sample of salt in the test tube, we added a little bit of water, little amount of water to it to just make it dissolve in water. So we got salt solution in the test tube, then we have added reagent. What reagent in this case? We have used caustic soda or sodium hydroxide, and we added, first we have to add drop by drop, and suppose this is the test tube, you have to put the reagent drop by drop and observe the precipitate. And you have to observe the color of the precipitate, what colored precipitate you are getting. See, in all the reactions, precipitate you are getting, that is confirmed. Then you have to observe the color of the precipitate, what colored precipitate you are getting. So only few ions are there that form colored precipitate. So we have seen reactions of these ions only. Then after getting the precipitate, we have to add the reagent in excess, and then you observe what is happening to the precipitate when the reagent is added in excess, whether it is soluble or insoluble. Now in the next session, we are going to see the effect of ammonium hydroxides to this salt solution. Till then, have a nice day.